groundbreaking news, or should I say space-breaking news from Interstellar Object 3I Atlas, because something happened that should not have happened, or should it have happened? No, it's a big surprise. 3I Atlas is still a single body, and that has stopped scientists in their tracks. What? So why should it not be one single body? Well, we have new images after it came out of perihelion. That's the closest point to the sun. And really, guys, imagine this. We have this object from outside our solar system. Interstellar object, interstellar visitor, and it's swooping in towards the sun. That is 3I Atlas. But many comets that are coming from afar do not survive this. They do not survive that kind of close encounter with the sun. Not intact. They break apart under this intense heat, the radiation, the tidal forces. So now fresh images showing 3I Atlas emerging from its perihelion, the closest approach to the sun, the dangerous point, as a single body. Is this another anomaly? We have already like 13 or so. It was crucial to ask the question, will it break up after perihelion or during perihelion? Because if it didn't, that's what Harvard scientist Dr. Avi Loeb, Professor Dr. Avi Loeb said, if it won't, then this deepens the anomaly, and it didn't. So that's why he calls it breaking news. Why is this strange? Well, this is strange or unusual because the data that we had before we see the new images, I'll show you the images in a second, guys. It will blow your mind. So before we see the new images that have been taken on November 11th, other data on 3A Atlas had shown massive jet structures. I've reported about this, at least 7 jets in my last video, all around the objects. Was that material streaming outwards? Jets reaching maybe 1 million kilometers towards the sun, away from the sun, and like up to 3 million kilometers in the opposite direction. So a normal comet, such extreme jetting as 3I Atlas had displayed, plus intense solar heating, should lead to breakup. And here we are, 3I Atlas is still in one piece. And here's the next surprise. I'll show you the images, I'll promise, but I need to get this out first. The calculations suggest that in order to produce the observed mass loss and the jets that we saw, the object would have had to absorb mind-boggling amounts of energy from the sun and have a surface area equivalent to a sphere 23 kilometers across, or like 17 miles or 51 kilometers if water, like ice, were dominant. But we have Hubble telescope imaging that limits its diameter to maximum 5.6 kilometers, like 3.7 miles at most. In other words, guys, the simple model of a natural comet doesn't fit. It just doesn't fit. And so we see this anomaly right now, a single intact body, huge jets, mass loss, demand that is incompatible with its size. And that raises the question, what is this object really? Is it a comet or is it something else? Whatever it might be. That's why it's important to keep an open mind. And now let's have a look at these new images from November 11th, taken with the Nordic Optical Telescope on La Palma. That's a 2.56 meter research telescope that is located on the Canary Islands. And from them, we have the big news that it didn't break apart when it went closest to the sun, like 2 weeks earlier. No obvious fragments visible if you look at these pictures. And that alone, as I said, is already surprising. And let's have a closer look at these images. The bright glow around the object looks a little bit stretched, like a smear. And that stretch lines up almost toward the sun. So astronomers call this a sunward anti-tail. I've reported about its anti-tail before, but listen closely, guys, this is different. So a normal comet's tail points away from the sun. An anti-tail is like a thin sun-facing feature that can appear, due to how dust spreads out or how we're viewing it from Earth. So tail, usually away from the sun. Anti-tail can look like, could be an optical illusion that it points towards the sun. But previously we've seen this was not an optical illusion. So the main elongation is about 106 degrees on the sky, and the direction to the sun is about 115 degrees. So that's very close. It matches with what Hubble saw on July 2025, when they first discovered 3I Atlas, a sunward tail, a sunward anti-tail, then two. There's also a weaker feature at about 301 degrees. That is close to the anti-solar direction, which is 295 degrees. So anti-solar just means it's going away from the sun. So couple of quick notes, because I know I can see that you have the questions in your mind. What does that mean? Well, perihelion is the moment when an object is closest to the sun. The position angle is important. It's just a on-sky compass direction measured in degrees. And at the time, on November 11th, when these images were taken, 3I Atlas was 1.43 astronomical units away from the sun and 2.16 AU away from Earth, closer to the sun than to Earth. And of course, the image scale is very big. The frame covers about 500,000 kilometers across. If we look at the image, north is up, east is left, and if you're looking at the technical figure, you see that fuzzy blub that is up to the upper left. That is a background galaxy, actually. And the little points that you see, that's stars. Isn't that amazing? And now you might ask, where are those jets? Those gigantic jets that we saw in some of the recent wide field images. And by the way, hopefully NASA will release their images that they took 6 weeks ago with the high-res camera soon to maybe give us a clearer picture. So those huge structures, these jets, one was reaching about 1 million kilometers sunward and about 3 million kilometers the other way, so massive. They do not show up clearly in this particular data set. They just don't. The likely reason? It could be the filter with which was used to take these images. These new images were taken through an R-band filter. So that filter lets in red light, but it cuts out many bright gas emission lines. So in plain English, if your filter blocks the main glow from gas, you mostly see dust and the central glow, but not the big gas-rich jets that are far out. So these images do not tell us that the jets are gone. Let's go back to these earlier wide field images of 3I Atlas, because they matter a lot. So if 3I Atlas is a natural comet, which we still think or estimate, although there's many things that are really strange, right? The gas jets should be moving at roughly the local sound speed for gas that is warmed at this distance from the sun. So about 0.4 kilometers per second. That's what its speed should be. At that speed, for a jet to stretch 1,000,000 to 3,000,000 kilometers, that activity would need to keep going for 1 to 3 months. So that's not just a quick, right? That's basically sustained outflow. So now let's bring the sun back into the game, because the sun isn't just light. It also blows basically a wind of charged particles, the solar wind. So those sunward jets seem to get stopped by solar wind around 1,000,000 kilometers. That's why they're maybe not longer like the other ones. Like 1,000,000 kilometers away from the object, the sun is blocking, it's stopping them. From that, you can estimate how dense the jets must be out there. So the back of the envelope number is a few million proton masses per cubic centimeter at 1,000,000 kilometers from 3I Atlas. Like proton mass is just a way to talk about very tiny mass units. Think like a lot of particles in each sugar cube of space. So then take that density and multiply it by the outflow speed, and then you get the mass flux. Basically, it tells us how much stuff is streaming out per unit area over time. And the estimate here works out to be about 5 billion tons per month through a square that's a 1,000,000 kilometers on each side. That cube, the sugar cube, 1,000,000 kilometers on each side. That's a huge amount of material. So where does that material come from? Okay, if this thing is a natural comet, its ice is turning straight into gas as the sunlight warms it. That process is called sublimation. So the energy cost, and I have to make this a little bit technical here, guys, but stay with me. The energy cost to sublimate carbon dioxide, CO2 ice, is about 800 joules per gram. So if the jets are putting out on the order of 5 billion tons of CO2 over about a month near perihelion, then the comet had to absorb at least 3 times, and now what's that in English? We say hoch in German, 10 heightened 18 joules. Multiply 10 by 10, 18 times. Joules of energy. You know how huge that is? From sunlight to power that. So it needs that much energy from the sunlight to actually power that. So when 3I Atlas was at its closest distance to the sun provided roughly 700 joules per square meter per second. So if you work that backward, you get the area that the object needed to absorb that much energy. So the math says, we always say math doesn't lie. The math says it would need more than 1,600 square kilometers of active absorbing area. That's like a sphere of about 23 kilometers across if the whole surface was doing the work. I think now, if you remember what I said at the beginning, maybe you're connecting the dots now, because here's the catch. The best size limit from the Hubble imaging suggests that 3I Atlas is no bigger than 5.6 kilometers in diameter, not 23. 23 kilometers is roughly 4 times larger than that. So that can't be a measuring error. If the outgassing were mostly water instead of CO2, the required size would even be worse. It would be about 51 kilometers across, because the water needs more energy to supplement. So where is this energy coming from? Because that's when people say, well, are these jets thrusters? So on real comets, only parts of the surface are active. You don't usually get the whole surface blasting at once. That makes the energy budget even harder to square with a small natural comet that stayed in one piece. How did it do that? So we have a puzzle on hand here, guys. Let's try to put this together. I find this fascinating. Whatever this object is, it is fascinating. So on the one hand, new images show a single intact body with a sunward tail, an anti-tail after perihelion, which is striking but clear. On the other hand, the earlier huge scale jets and the energy needed to power them don't easily fit a small natural comet that didn't break up into lots of other fragments. So let's say if it were natural and still intact, where did all that sustained massive outgassing come from? The numbers strain the usual comet picture. And I've seen some articles that try to debunk Avi Loeb's theory, for examples, that they have been released in some science-based newspapers. But then I look, okay, who wrote this article? A marine biologist. So who has the better expertise in this? This is Avi Loeb's bio. And marine biologist, well, yeah, you look underneath the surface of the oceans, not high up, right? So this is really something, in my opinion, that we really should absorb with curiosity. What I just told you about 3I Atlas, this is what people and scientists say. Are we missing something in the standard explanation of this, in the scientific explanation of this? So it's healthy to look both ways before crossing the street, right? You look left and right. A famous line that is often paraphrased is, knowledge says the street is one way. Wisdom checks both directions anyway. In other words, don't ignore anomalies just because you're inconvenient. That is really something good, because we see this in areas that are prone to natural disasters and catastrophes. People tend to ignore it. It's going to be fine, right? Nah, that's never going to happen, right? It's inconvenient. It would be inconvenient if a magnitude 9+ earthquake would destroy a mega city on the West Coast. It's inconvenient if a volcano blows up in a city like Naples, one of the world's most densely populated volcanoes, not areas in the world, right? So people tend to say, no, right? So I think this is a good example. But there's another possibility that people tend to bring up. So they say, think technological thrusters. If an object had engines that point their exhaust towards the sun, the push would kick it away from the sun. Yeah, of course, right? We've all seen the Enterprise movies, for example, Star Trek, right? So doing that after perihelion, after it has swung around the sun, basically, it could be a smart way for a spacecraft to gain extra speed instead of slowing down from the sun's gravity, right? And here's why that matters for the energy and the mass numbers. Natural comet jets are slow compared to rocket exhausts. Sun-warmed gas leaves at a few hundred meters per second from the comet. Chemical rockets throw exhaust out at 3 to 5 kilometers per second. Ion thrusters can reach 10 to 50 kilometers per second. Higher exhaust speed means you need far less mass to get the same push. You know what this is hinting at? It sounds crazy, but it somewhat makes sense after the mathematic calculations we just heard about 3I Atlas. That's why I said stay with me, right? So if The push on 3I Atlas is real and sustained. A technological system could, in principle, do it with much less material than a natural comet would need. To make this crystal clear, the November 11 images say the body is intact and show that sunward anti-tail. They don't prove engines. They don't. The energy budget argument is the part that stresses really the natural comet model if we insist on a small single body and on the huge jets that are lasting months. That's the tension and that's the problem that we have here. So either we're all missing something about how a small natural object can power and shape these gigantic structures like the jets for such a long time without breaking up, or we allow room for a non-natural explanation. Right now, the images that we have plus the numbers tell us we can't just wave the puzzle away. So that's the anomaly. The energy needed to power those giant jets for 1 to 3 months is hard to square with a small natural comet that stayed intact. But that's what 3I Atlas is displaying on the images. So guys, I'll stay on this for you. It's fascinating, but there's a lot of stuff happening down on Earth. But you never know. I have a 3I Atlas playlist that tells you everything you need to know, but there's other stuff going on as well. We have new information about the underwater volcano axial seamount. And guys, have you seen that bridge collapse in China? Well, the bridge did not collapse by itself somewhat, but a mountain collapsed. Did the mountain collapse because the bridge was built? It was brand new, and then they caught it on camera, and the mountain gave a warning, and thankfully the authorities evacuated. But the images are absolutely crazy, guys. So subscribe, hype, and like this video, share it with your friends. Thank you for supporting the channel. If you want to buy me some coffee, link is in the description. And really, I see you there in a second. I promise you won't regret it.